much review, right? But the idea here is, the early web being kind of characterized by open protocols that were decentralized, community governed. For those that were around, building apps back in the mid 90s and the early days of the web, is very different than it is today. And it was really technically challenging, right? Most users at best were able to consume content, right? They were readers. They really didn't have an opportunity to contribute directly unless they were fairly technically savvy. And, there were no native identity and payment layers. And so what we have today, which is a great move forward in terms of accessibility and allowing your average person to be able to connect and use digital services, was largely built by a number of platform companies that help create these user-friendly services, oftentimes offered for free, right? And that underpins kind of the current model of advertising-driven applications that we enjoy. If you heard the phrase of if the product's free, you're probably the product. Hopefully that resonates with you. But a lot of this kind of contributed to this view that there's an opportunity to try to build a better web. And looking forward, that's really what we're trying to build within this community with all of you, right? And TBD is trying to be part of the kind of motivators to catalyze this ecosystem, but ultimately this will succeed if there's a whole community that grows up around it and developers can build applications and ultimately users and companies find value in that. So kind of looking forward, like towards how do we get to this user-centric network that empowers individuals and gives them access to financial services, digital services, and some level of equitable access that we'd love to see. And that kind of takes us to this concept around a set of foundational components, things that we believe could be a key part of building a new web. And all of these should be very familiar to all of you that have been around the project, but just to kind of run through them quickly. For context, right, decentralized identifiers, being able to provide individuals a way to own and control their own identity. Verifiable credentials as a mechanism to enable the possibility of conveying trust and establishing reputation and being able to validate that in a automated way. And then the idea that most applications, with a few exceptions, they're probably not ephemeral, right? There's a data component to them, and there's a need to be able to do this. And ideally, in a scenario where it's not just we're all uploading all of our data to some small set of large data lakes that have all of our images, text, music, and so on. So this idea of how do you actually then take those concepts of DIDs, VCs, and a data store and kind of bring them together. And so this, is kind of incrementally moving towards the architecture that we've implemented, but giving you some of the motivating factors of why it looks this way. And so taking, kind of the foundational layers that the internet itself was built on, that the World Wide Web was built on top of that, right? We're not looking to replace any of the core protocols that exist today and that power, most of the experience that we call the web. And that, foundationally, whether you look at it as the OSI model or you look at it as a set of building blocks, right, built on the internet protocol with these, layers on top of it, like UDP, TCP built on top of that, things that are probably more familiar to developers that we use every day, DNS, HTTP, WebSockets, and, some of the newer methods, but, ultimately they're network protocols, a way to do something like resolve a DID, given its string value, what does it actually, dereference to? And on top of that, these three kind of pillars that we've tried to group these concepts around. And so ultimately what we'll talk about today, this Web5 SDK, this platform SDK that's built, made up of a lot of different components, is trying to provide a generalized abstraction that enables you to access, use, power applications using all these underlying technologies and concepts, but not necessarily, having to build them from scratch. And for anybody that has been, in this space a long time, right, there's an old saying of friends don't let friends, create their own crypto libraries. There's a little bit of an extension to that, which is at some point it becomes a Herculean task to put all this together, just to get to that first, I built a hello world application that, did something simple, right? And so part of this is we're trying to provide these batteries included SDKs that make that easy to get started and ultimately allow you to build applications on top of this. And that's where really the value is, right? Ultimately, what we're doing as a community, what PBD is contributing to, is the building blocks to help create the app. But that's still where we are most excited to see people building, giving us feedback, and helping improve the underlying toolkit that exists. So how does that look? What is the actual experience, right? We'll talk about the components, but maybe to map, from this picture of DIDs, VCs, and DWeb nodes, how does that, start to look when you're a developer building an application? And, not surprisingly, organized kind of a similar manner, right? With this idea of when you initially instantiate your application using Web5 stack, you get back effectively this instance called Web5. You get back a DID, which is the identifier that is being used to interact with other applications, the data store itself, issue credentials, consume and receive and accept credentials, and so on. They have these kind of convenience methods that we've tried to expose that do the job of trying to map that mentally to code. So for the creation of a DID or the creation of a verifiable credential or the instantiation of a DWeb node, you have effectively this set of interfaces, each of which is one of these three pillars. And then you have a set of methods that hang off of them. And so, as an example, to create a new record, it's web5.dwn.records.create. Or to delete a record, not surprisingly, it's web5.dwn.records.delete, and so on, right? And so the API itself is effectively the interface through which hopefully most applications can be built. And we want to keep refining and improving that to make that simpler and to have more of those functions kind of elevated and exposed as a top level API. So this is an area that we'd love to get feedback on as, things become kind of sorted into the 80% of people need to do this to build apps versus there's probably always going to be a 20% where you really need to get under the hood, get to some of these core libraries we'll talk about. And that's okay. But in general, we don't want to miss the 80%. So this is the idea behind these. You're not supposed to be all inclusive, everything you could possibly do. And then, I guess to extend that, there isn't a bit of opinionated approach to this. For example, we have chosen to use certain DID methods. There are many DID methods, dozens of them. Each of them has different trade-offs and different use cases that they're designed for. And so if somebody has a reason to build with, for example, DID web, which is currently not part of the library, there's nothing that stops you. And we've intentionally made it possible to say, look, when I instantiate this Web5 instance, I in fact want to use a different DID type for certain purposes. Or, if there is a reason to replace the underlying data store, right? By default, the DWeb node uses level DB under the hood. We've provided options to use things like a SQL store instead. But if somebody comes along and wants to provide an alternative, there's a hook to be able to override that default. But as much as possible, and I think a core kind of principle that we try to implement across all of these interfaces is whenever possible, a simple kind of quote unquote good default. And I think, we've been motivated on that by using other SDKs and libraries in the decentralized web ecosystem that oftentimes, because of the nature of their flexibility, they present the developer with this initial, we need to select 100 different things just before you can get started. So what we've tried to do is select a set of reasonable defaults, but always provide a way to override. And there are some cases where that is not exposed yet. So that's, again, another area for feedback. If there's something you find yourself having to override deeper in the library quite frequently, would love to hear about that, talk about how we can make that even simpler to do. But taking from this upper layer, kind of the external API of how you can create credentials or DIDs or records or other activities that would be part of creating an application, there are basically these components that sit under the hood that power this. And so at the kind of continuing from the last discussion of the top level API, not surprising, it's called Web5/API. It's a package published to the NPM registry that you can pull in and use. And that is where things like Web5 dot, fill in the blank dot something exist, right? Web5.ddbn, DID, and so on. And those ultimately, are kind of the primary avenues that we would expect most people to interact with. But under the hood, these APIs are essentially making calls to a set of reference implementations that are somewhat opinionated versions of things, or in some cases, they're just implementations of a standard. So starting with one that's probably familiar to everybody here would be the DWN SDK. It's a reference implementation in TypeScript of the DWN spec that is part of the Diff Foundation. And that is consumed today. If you're eagle-eyed, you'll notice there's a discussion today about what the NPM org should be. So there's a discussion of moving that to Web5. So I just went ahead and put that here. Today it's pulled in as TBD 54566975. But that could change. So the DWN SDK is kind of a core piece, right? It's what powers the pillar around the data store. And then there's an additional project called DWN Server that you can consume as a Docker container or as a NPM package if you wish to build and extend, let's say, add new RPC methods, add your own extensions to it. It's published as an NPM package as well. And the DWN Server really is there to wrap network connectivity around DWN SDK. So for those that have played with it, you can instantiate it in memory, you can use it in a project, but it's not opinionated about how you might interact with that DWeb node across something like a network boundary. And so implementations of protocols like let's use HTTP to interact or WebSockets, or fill in the blank. It could be DIDCOM. It could be something more interesting like I want to interact with it over Bluetooth, for example. It doesn't particularly matter, but you can implement your own transport. DWN Server is simply just a reference implementation of what it would look like to use HTTP and WebSockets to make calls over a network, expect some message to be processed by the DWN, and then get that response back. And it leverages, like you might expect, traditional HTTP status codes and the like to communicate back and forth with some remote caller that's executing messages. And then the part that might be a little newer to folks, and this is something we'll talk a lot about today, is kind of core to the design we've taken, is this idea of having agents that carry out on behalf of ultimately the end user, the person who's using the app. But as a developer, right, you're facilitating that interaction using these agents. And for those that have been around the web for a while, you're probably aware that your web browser itself is considered a user agent. That term is sometimes a little bit confusing to folks, but really, it's this idea that as a person trying to interact with just generally the web, right, you don't want to hand roll your own TLS, packets and do verification of certificates and root CA authorities. And, you don't by hand go and curl the DNS names to get back the IPs to type them in, right? The browser does that and many, many other things for you as your agent operating on your behalf. So as a person, you're the user, the browser is the user agent. It enables you to interact with the web through familiar point-click keyboard type interaction. And similarly, these agents in the Web5 stack are, sitting on top of all those traditional networking and web protocols, but they're facilitating the functionality that, again, we don't want a person to have to think about the cryptography or what it looks like to actually verify digital signature. We just want you to be able to know that that message is authentic or that it has confidentiality because it was encrypted in transport. And so as a developer, you don't have to go in and actually interact directly with those core libs, but they're there and provided for you. And so we'll talk a little bit about the difference between these two things, but the user agent is primarily what would be running in a browser tab when you're building an application. It's how your application would interact with DIDs, VCs, and DWeb nodes. And the identity agent is very similar, with really the main exception, I guess the difference being in the scenario where it's not an app like a browser tab where you're using a chat app or music files or photo gallery or whatever it might be. It's actually an application that's specifically intended to manage your different identities, because we do believe that it is quite likely. In fact, we would encourage people to have different personas or different identities online. Most people already do, right? You have kind of your LinkedIn profile, perhaps, that probably presents a slightly different version of you than might be the case on a chat application, or that might be, different than maybe say a photo sharing app that you share just with your immediate family, right? To share, pictures of family vacations or something. And so those are kind of different personas. You're the same you, but you want to have, not just one identity out there that all of that activity can be linked back to. And so the idea behind the identity agent is simply it's a way to take these sets of components that we've provided and bring them together in an application that's really just designed to handle that connecting back and forth, switching back and forth between them. And to the question that's in the chat, so there's a very long debate about the term wallet. For those who've been kind of in this space chatting for a while, right? There's a set of kind of implicit understandings people have about like what a wallet is, right? We've tried to map that back to like the physical world. And the challenge also with the wallet is it doesn't really imply what's happening here, right? It's not just a repository for things like, in the physical world, your identifiers, your payment cards. In the digital world, we often try to map that to like, well, that's where the VC sit or your identity sits, or maybe a key that you use to transact in a digital asset network. So the idea behind the agent, which thank you, Angie, for posting that, a lot more details to kind of read through there. But the idea behind the identity agent and the user agent themselves is they do store keys and credentials in your DWeb node, but they're not, let's say, just a wallet, and they're not, I guess, limited by what you might think of as a wallet, but they do have that functionality. And I think something to, I guess, keep in mind there is that it's not intended to be a replacement for something else. So as an example, one of the companies that we're talking to that is looking to build on the Web5 platform, they don't want to introduce a net new application, right? They want to have the ability for their customers to be able to link their existing account, which is, a centralized system, right? Some row in a SQL database somewhere, which is like your user ID and your credentials and a salt or something, right? To map that to a DID and a key set. But ultimately that doesn't have to live in one specific place, right? And so a lot of the stuff that we've been thinking about with our design team is, and looking for feedback is, what is the different ways that we can make that transition easier? Because what we don't ideally want to end up with is a scenario where when you start on one browser on one device, you end up with a set of keys that are effectively your way to control that identifier and your access to your DWeb node, and you have to manually export and import this set of files around to all the other devices you might want to use. So we'll I see the note there about being confused. We'll try to kind of elucidate a little bit more on that. But ultimately, these applications at this level, these implementations, they're really built on a set of foundational libraries. And I just want to call out this. This is a little more under the hood, but since we're talking about like the architecture, this is the low-level architecture. And so under the hood, there are a set of libraries that we've been building. These are not all entirely, just written by us in the community. There is import sharing of these packages with other libraries that exist. So, for crypto libraries, for example, we're using well-known audited libraries. For credentials, the same scenario. So some of these things are, being created specifically for these applications, but oftentimes, much like many things in open source, right? It's an open source community of different teams building different systems that get pulled together to build this experience. The common package is basically just the very common utility functions, types, and supporting kind of functionality. We don't want to reinvent the wheel and duplicate everywhere. So not super exciting there, but a good way to keep the project organized. Credentials is effectively the underlying primitives for interacting with verifiable credentials, verifiable presentations, doing things like presentation exchange, and will be extended over time. And, as I go through these, I guess I'll note, it is possible to take these libraries and build something that has nothing to do with, these things that we've implemented up here. And in fact, even within TBD, there are teams doing just that. So the idea of, as we, build a variety of applications, some of which are going to be, leveraging these kind of reference implementations that bring components together. There are other projects where, hey, I just need a crypto library. I just need, the ability to create a credential, for example. And so rather than trying to, again, have a bunch of duplication and a bunch of different projects that we would then have to maintain and have audited over and over again, we're building on a common set of capabilities that we want to leverage extensively. And, we'd love to see others in the community do the same, whether or not they are today building specifically, what looks like a Web5 app. But crypto, all the crypto algorithms, block cipher, digital signature algorithms, and so on, those kind of live there. Interactions with DIDs to be able to create, update, recover, deactivate, and so on. Primarily today is just the two that we're using, which is did-ion and did-key. But much like all of the things we talked about before, the ability to override those with a custom implementation, maybe it's a tweak of what we're doing, or maybe you're using a different endpoint to anchor DIDs, or it could be a completely different DID method altogether. So the idea is that kind of similar interface can be used with other implementations under the hood. And then lastly, the agent library is basically the components that we'll talk about in a minute of like what's the functionality that makes up an agent? How do we actually then take this functionality and expose it for the Web5 API? So this picture here kind of is a break down the components and kind of map them to these familiar pillars that we've been talking about. So this kind of top row here is essentially the Web5 API we were just discussing. So, Web5 dot the component, like did VC DWN, the interface, for example, records, and then the method, like create. So if I want to create a record, I would go through and use that specific function call to make the new record get created or create a new DID or so on. And so effectively that Web5 API that sits at the kind of external top layer, under the hood, what it's doing is it's essentially making calls either directly because they're running in the same process to this underlying agent that we talked about that has this functionality. We'll dive into these in a second here. But the idea is that each of these has kind of a corresponding underlying agent management interface that carries out the request that was made. And so these APIs are fairly simple. Their job is simply to make ideally as most ergonomic and kind of improved developer experience as possible, because some of the stuff under the hood gets a little bit, complicated, and there's lots of decisions to make about how things are done and how many parameters get passed. And some of these underlying methods are very flexible in that. And so we simplify at the API level so that it's fairly straightforward to do something. And then they make these calls to these individual, kind of management layers that take action when you say, hey, create a DID for me, right? Which could involve a whole series of steps, including the creation of one or more key pairs, sometimes 3 or 4 key pairs, depending on the method. And then actually creating a decentralized identifier based on that, doing the resolution of it, passing back a fully resolved DID doc, for example. What you see is the return back, but under the hood, a lot of these different steps were taken. And the kind of supporting things that sit alongside the basic 3 pillars are essentially the components that help actually manage some of the underlying aspects of what the agent does. So there is a secure app data vault that's here. This is for local storage. So rather than just like dropping it into, whether it's a node environment to the file system in a browser, might be to something like IndexedDB or local storage or elsewhere. This essentially gives you a common interface to that. And all of the data that gets stored in that app data vault is encrypted. And it uses a very similar approach to doing that, where you securely encrypt and then can later decrypt based on a passphrase. So if you're familiar with 1Password or LastPass or any of the pattern password management services, they have a similar model. There's a vault. You can store sensitive material in that vault that you want to remain confidential, and presented with a key and a passphrase, you can unlock it, decrypt, and use it. And so that's essentially what we use to store a limited amount of information that the agent needs to start up. And the primary thing that gets stored there is actually the private key of the agent itself. So when it first starts up, it has to be able to interact with the DWeb node. You can't store the keys for the agent in the DWeb node, right? It's kind of a cart and horse problem. So you need to store them somewhere else securely. And then upon presentation of the correct passphrase, we decrypt, and we can then use that to start interacting, at the application layer, writing and retrieving data, sending network requests, and so on. And there's these other supporting methods that exist here too. Probably not surprisingly, key manager is responsible for managing cryptographic keys that are used, both the asymmetric variety that are typically associated with the DIDs that are being used, but also from the symmetric keys that are used for things like encrypting records. And then the identity manager is basically an interface across this. When you think about from the perspective of a application user, right? And we talked before about you might have a career identity that's created. It's got a DID, a key set. They are distinct from your, let's say, work one, which is distinct from, say, your family or personal one, right? This is the ability to basically interface with those and all of the underlying records that are kind of grouped under these different identities. And if you were to switch from one to the other, you switch through this interface. And at that point, if you're accessing, let's say, a decentralized chat application, right, you might be at a certain handle with a certain social graph of people you're interacting with. When you switch, right, that would all change accordingly, and it would be as if you're a completely different user. And then lastly, on the network kind of transport side, so we talked about a little bit of this before, like DID resolution, right, is potentially in some cases very simple DID methods like DID key can do this locally. But for many DID methods, there is some concept of an anchor or a central ledger upon which these records are written to be able to validate that they are in fact the latest state of that DPKI. The DID resolver makes those network calls to actually do that resolution for you. The sync manager is something that is part of how we actually synchronize the web nodes. So if you have a local one, you might have one that's publicly addressable. You might have several others that, for example, one might run on a mobile phone, right? That's typically at sleep. How does it know about new records that you might have written somewhere else, right? Sync can basically make sure that that state is consistent. Today, that's kind of an all or nothing thing. You can turn it on or off. You can set how frequently the sync interval occurs. In the future, one of the things that we're putting as a high priority is to do essentially selective sync. So, there may be a case where you have an application that I only want to receive the records about, the chat application that I'm responsible for. I don't need any of the other data that might exist. And there may be a huge amount of data that's available that's stored on your behalf, all the different kinds of apps you might interact with. You probably only want to sync a small subset, which is, probably not surprisingly super important on mobile, right? Limited data space, limited bandwidth, oftentimes, especially in many geographies, it costs money to move data to a mobile device, especially over the carrier network. So, that's a key feature that we believe's got to get done pretty shortly here. And we have that tracked for the next cycle here. The RPC client is one that's used to make calls over the network. So this could be a scenario where your application is running in your browser and the DWeb node is in memory, it's in process, right? It's available directly. But we also have scenarios where that needs to happen over a network boundary. And the most, obvious one, I guess, for anybody that's played with this, we host, a set of TBD nodes that people can use. You're welcome to host your own. There will be other service providers in the near future that will host them for you as well, for your users. But that's how we make calls over that network. So using standard JSON RPC, the functionality, we can basically, request that a record get written by a DWeb node, hosted in a data center 1,000 miles away, or, hosted in your house where you have your own, device that you want to maintain network access to. Or in the future, it could be just between, two of your own devices. And this is the case where today that's being done through fairly traditional means. One of the things that folks in the community have talked about and would love to see, if somebody else doesn't get around to doing it, we'll probably eventually get to it ourselves, which is to do this in a more peer-to-peer fashion where you don't need to have publicly addressable, open ports to go through NATs, so think of hole punching, those kinds of things. But ultimately today, that's, part of the way that any network call gets made. It gets handed to the RPC client, then over the network, response comes back. and it looked like, the same exact response you would get if it was an in-memory dweb node or request to create a did or so on. And then the last one I'll kind of allude to, this is something that could be a topic in and of itself, but getting back to that discussion we had before around, the life cycle of the first time somebody uses some type of Web5 app, a did may be created and keys stored locally. At some point, hopefully, if the application is something they find value in using, they'd want to access it from another device, or they might want to use that same identity across multiple applications, and then maybe create a second identity that they use in another context. Maybe it's an anonymous, identity they use in certain chat applications or social networks, for example. The core thing we're trying to do there is to make that both kind of onboarding process as well as the life cycle fairly convenient, ideally as convenient as possible, not looking like I have to download a bunch of files, figure out how to email them to myself or airdrop them or what have you. And so this idea of did connect is with the basic premise of how do we use dids to connect from one application running on some device back to an existing identity or identity app that you have, and then be able to, on behalf of your existing identity, use that new application so that you could potentially have, the same identity across n different applications or, the same app across n different devices. So again, I don't want to, I guess, try to trivialize that. There's a lot there, and that protocol we think is going to be a powerful part of how it becomes fairly seamless for end user to interact with applications. But there's a lot to it, and that's something that's currently being implemented in several of the projects. DDBN server for the connection point to facilitate being able to meet in the middle and connect, even if devices are behind that. And then additions to the Web5 JS kind of library of packages that expose that and make that simple. And so for those of built apps already, you have this web5.connect. Today it essentially connects to a local in-memory agent that has its own dweb node and key store and so on. That same web5.connect will allow you to connect over a network boundary to another agent or another application running and facilitate kind of getting bootstrapped with what did do I use, what keys can I use to send things over the network. So the current, just for the question that's in there, I'll just touch on. So record encryption is actually something that had gone under a fairly significant change in the underlying DDBN SDK to improve both the security and the flexibility in using it specifically with protocols. And so that is something that is still a open task to actually implement that completely within the web5.ddbn.records interface so that you can essentially pass what would be fairly simple, like a Boolean that you want that record to be encrypted, or in the case where the protocol mandates that all the records in that specific protocol path are encrypted, it would just happen automatically. And so that work is ongoing to actually bring that functionality in without necessarily exposing all the complexity of managing both the symmetric keys that are used to actually encrypt the data, but also a set of asymmetric keys that are used to encrypt those symmetric keys to make it fairly easy to distribute to a variety of parties that you might want to access that same piece of data. So think of a case where photo sharing app or a chat app, right? You have a thread with a set of participants, or you might have a group that share a certain album, right? All of them ought to be able to decrypt the same data and read and interact with it and write their own records. There's a lot of complexity under the hood there that allows that to be possible, but ultimately we want to kind of wrap it in a very simple interface. And so we're trying to take some time to think about how that might get done in a really developer-friendly way. So I guess as we're kind of coming to time here, I do want to leave some time. If there are other questions, feel free to post them in the chat too. But just to give you kind of another view on this that hopefully helps some of this kind of mental model make sense of how these things fit together. The SDK components are essentially, in a sense, they organize, they flow this way in terms of their interaction. So when you make a call like web5.did.create or web5.ddbn.records.create, what's happening under the hood is either directly in memory or, like we talked about, over a network boundary using a transport protocol. I'm sending that request to the agent. The agent is responsible for carrying out that request. And so, to take you through kind of a pretty common example, right? If I were to write a record, part of what has to happen is, I have to be provided with the data. Use a developer, writing this code. Here's the data. Here's the schema, the protocol, or maybe just simply the data format that I'm writing this data in. And then under the hood, effectively, you have to go get a set of keys that you're going to use associated with the did that needs to get written. If it's local, you would find that message, hand it to the underlying DWN here, and it would be processed. But if it's remote, right, after you actually sign that message, you then have to take it, serialize it, transport it over, let's say, HTTP or WebSockets in the form of an RPC request. That would then get processed remotely, gets all the way handed back, and eventually kind of bubbles back up as your response, right? The agent is responsible for taking all of those actions. And similarly, things like creating a did we talked about before, that involves key creation, did creation, storing that information as a set of records, right? That looks like one call to you, but ultimately under the hood, there's a lot of things that happen. And these, methods that we saw before, it's the exact same set of components. It's just organized to give you a sense of like all of the commands end up flowing through the agent carries them out and then passes them back as a response. And to kind of round it out, we talked about app data, key management, creation of keys, signing of messages, verification of messages, encryption and decryption. Part of why this isn't just bundled into something else is that a lot of these functions, right, credentials, DIDs, and DWeb nodes, they all rely on cryptography, right? Typically at a minimum, digital signature algorithms. Often some of them require encryption as well. And so the key manager is responsible for taking those actions on behalf of the application. And it's built in such a way that that is abstracted. And so while a simplistic implementation and the current default is to do that locally with a local key store that's encrypted, the opportunity exists, and actually reference implementations already kind of are stubbed out, which is what would that look like if I were using AWS KMS or Google Cloud KMS or some other provider of an HSM solution that is the only place that my private key material exists, and I need to provide any data to be signed or verified, for example, to that other system and get my response back. It makes the calls look identical for all these other functions. And so, a bit of code that's signing a message to write to a DWN or that's verifying the signature on a verifiable credential doesn't have to know or care where those keys exist and are they in a data center 1,000 miles away. It just hands that over to the key manager and says, do this for me and return it back. And then lastly, for the question about identity manager, so essentially the identity manager is really just aggregating the collection of things that are part of what is an identity, right? So if you were to create initially your first one and you use that for like some social chat application, and then you create another did and keys and start creating records for maybe a professional identity you use for a different set of apps that are more, your career or work persona, those are all created by the identity manager. So each of those things could be done manually yourself, but it creates a convenient interface so that you can say, hey, create a new identity. I'm going to call it, Frank's social identity. And when that gets executed, what actually happens, right, is a whole series of keys, a did, a set of records, and a protocol that is part of that profile information that has things like a display name, a social handle, and so on. Those things all get written with a fairly simplistic, make one call, lots of things happen, I get a response back. But ultimately, it's a common interface that we have already run into ourselves. And so we presented it as kind of a simple way to do that. But again, all of these things are really a collection of things built up on DDBN SDK, the crypto libs, the credential libraries, and all those primitives around did methods and so on. And this is, simply an attempt to create a simple interface that, quite honestly, for those of you on the call, most of the time you shouldn't have to know or really get too into the weeds on all this that's kind of below the API line. And like we talked about, I think there's some aspects of this that are already exposed and easy to use. There's probably some other things that are, you got to dig under the hood to get to surface that function you need. And if that starts to become hey, most people need to do this, that's an opportunity to kind of improve the external API. But we also want to try to balance that trade-off of, if it's too much of a Swiss Army knife, there's too many things exposed, it can get quite confusing. So looking and appreciate feedback on that. And I guess just to kind of round out, so road ahead, from where this was started, for those that you remember the first few tweets about TBD back in the summer of last year, and all the work that kind of went into getting to what was initially the tech preview, showing off the early versions of the Web5 SDK powered by the DWN SDK and the DWN server. Our goal is to basically get to a place where all the core platform features are complete and the APIs are stable. And then, basically a plan to kind of launch that initial platform layer in November of this year with some demo applications that we want to show off, just to give people examples of like, what does an app look like built in this way? There are some already that are existing, right now, some simple apps, but what we found is that it's really helpful for people to, who've built apps in, let's say, kind of the traditional or Web 2 way, to have a reference example of those same types of apps built using this stack, this platform. And then the goal is to have kind of a demo version of the identity app we talked about that would allow you to manage 2, 3, 5, however many make sense for you, different identities you can switch between. You can use Connect to bring them to any device that you have, your mobile Safari browser, your Android tablet, your second computer that's not your work computer that you want to log into, right? How do you seamlessly bring that to all those devices? Because unlike a centralized, federated or centralized identity platform, right, we can't just go back to some central service and ask it to help authenticate to each app. Essentially, we're asking the individuals at the edge to be controlling of their identifier. And so that provides, and also opens the door to some responsibility to actually doing that. And that's something that we don't take lightly and want to make as simple and seamless as possible, and not have that be a hurdle for adoption where it's just too complex for people to figure out. But ultimately, that would then lead from kind of the demonstration of the platform for people to build apps on top of, to finally having the apps in the App Store, for example, and build out a lot more applications that we have been talking to different partners and members of the community. So we expect by that time frame they'll be able to start showing off some of what they've built, and then a lot more on developer programs, dev enablement, and the great work that Angie and her team have been doing to kind of continue to round that out and just make it easier for people to get started and get to that first win, get the hello world going, and then build something a little bit more complex than that. So with that, I'll kind of wrap it up. If there are any more questions, I think one thing people often ask about is like, what's next? What's the roadmap? So this recording will be out there. I'll drop this link in, but there's an open public board. We use this ourselves. We don't have a second board or something. This is our way of tracking kind of what's on deck. It's both by feature, but also by priority in terms of what's up next. Welcome to feedback or, things that people want to hear more about. And I'll take any other questions. As was said earlier, please feel free to keep putting them here on the Web5 channel, and we'll check them out over the next week or two. There is a comment there about just like cross-platform. So, one of the things that we've already been in discussion with a number of teams, including those that Block as well, the idea that, there's lots of different runtime environments and development environments that organizations are already committed to. So if you're starting out today, that's probably an easier situation than if you've been building something for 5 years. You're not going to re-platform or change. And so one of the things that we're kind of doing partly as an ecosystem kind of effort, because many of these things have already been built in languages that are easier to be cross-platform. WebAssembly is one that was mentioned. Things like surfacing bindings for underlying dev kits that are written in other languages is another, but that's an aspect to it that is certainly top of mind and something that, at a minimum, to have kind of the basic functionality that you could build an application that could interact with DIDs and VCs and then VWeb nodes is an area that we're putting some effort into to make it possible to do things like native mobile apps. Think iOS Swift and Android Kotlin shops, for example. And the other side would be the implementation of the backend services, things like credential issuance and managing of DIDs and keys for the enterprise side use cases. So certainly more to come there, and cross-platform is certainly an important aspect of adoption, and obviously one, over time we'd love to see more people contributing and kind of building, hey, this matters to me, I built this, I contributed as an open source project or component or just